Today we're going to talk about the different groups on the periodic table and some of the properties that you need to know about them. Traditionally, groups were also referred to as families. Keep in mind when we talk about groups, we're talking about those up and down vertical columns in the periodic table. There are several what we call representative groups. Group 1 and Group 2, Group 17 and 18 are specifically our most representative groups, being they're extremely predictable. Group 16 kind of falls under this as well. But the groups that we actually talk about by name are Group 1 and Group 2. Group 1 are the alkali metals, Group 2 are the alkaline earth metals. Group 17 are the halogens, Group 18 are the noble gases. That middle section, that kind of shorter, squattier area on the periodic table, you should know as the transition elements or transition metals. And generally, when we talk about anything in groups 14 through 16, we're talking usually above the periodic table or above the staircase. So we're talking about nonmetals. So some properties that you need to know about group 1 alkali metals. They're very reactive with water. As you already know, in terms of a chemical property, they lose one electron to form a positive one ion. They're extremely reactive, so they're not found freely in nature. Now, Group 2 is similar to Group 1 in that they're also reactive with water. They are less so than Group 1. They're a less reactive group. However, they're still very reactive. They lose 2 electrons, form a positive 2 ion. Neither of these groups are found freely in nature. They're only found in compounds. So they're just so reactive, they will always find something to react with, even just moisture in the atmosphere, in order to form a compound. They're just not going to stay in their elemental state. The metals that we're more used to thinking about as metals, things like iron, chromium, things like that, things that we make stuff out of, nickel, copper, silver, gold, are all considered transition elements. They form positive ions. Many of them have multiple oxidation states. The need to know fact about these is that they form colored solutions. So if you think about some of the copper stuff that we've used, copper sulfate lab where you had to evaporate the water from those blue crystals, their compounds and solutions, when they're associated with water, take on colors, basically. So you might remember also seeing some of our solutions with copper in them are the ones that look blue. These are less reactive metals, which makes them better for things like building structures and day-to-day usage and wearing in jewelry, etc. It also is why they tend to be a little bit more valuable, a lot of them. So they can actually be found in that and used in that uncombined form. Although it is important to note that a lot of these metals are not being found in the pure state anymore because we've depleted a lot of the ores found in nature. Groups 14 through 16 above the stairs, when we're talking about the nonmetals, this is where we get into negative ions. They may bond by gaining electrons, or they may bond by sharing electrons. So there's a little bit of a variety in properties there. We're talking about nitrogen or oxygen, which are gases, phosphorus and sulfur are solids. So we have a little bit of variety between these groups, but generally it's important to understand they do not lose any electrons. Group 17 are the halogens. These all form -1 ions. They're all diatomic. They're found in all 3 states of matter. Fluorine and chlorine are gases, bromine is a liquid, and iodine is a solid. So this is the only group on the periodic table where you can actually see elements in all 3 states of matter. Halogens are also very reactive. Because they're diatomic, they're usually reacted with one of their own. For example, like chlorine is Cl2. So you can find them in an elemental state, but they are bonded to somebody. So they bond really readily. They can bond with other metals really readily, with other nonmetals. They're sharing electrons. They're very reactive elements. And last but not least, in terms of being reactive, the complete opposite of this is the noble gases. Noble gases do not form ions. They're non-reactive. And they're what we call monoatomic. You can actually find them in a single atom form, floating around. They're obviously all gases at STP. The metalloids are the elements that are right on the staircase. There can be a little ambiguity here in terms of what does it mean to be right on the staircase. Boron and aluminum we don't really count as part of this. So our metalloids are silicon, germanium, arsenic, antimony, tellurium, and polonium. In terms of what their properties are, there they are. Properties are between a metal and a non-metal. So a lot of these elements we're going to find in the lab do some things that we expect metals to do. For example, we'll look at a sample of silicone, which will conduct electricity a little bit, so it will do some conducting. However, if you were to hit it with a hammer, it's not going to be malleable. So these properties are intermediate between a metal and a non-metal. You can tell by looking at them, they do have some amount of luster to them. However, they also kind of appear to have what you talked about in earth science, which is cleavage. If you hit them with something they're not malleable, they will break. The last slide that I have on here that we're going to go over in class, there are a lot of great videos online of people reacting, alkali metals, especially with water. Some of these are slightly fabricated, but if you're so inclined, there's some great videos out there of people, putting a sample of sodium or potassium or rubidium into water and watching the fun go from there.